Okay, the Pythagorean Theorem is chapter 12.2, and a guy named Pythagoras came up with this in ancient Greek, in the Greek times, in ancient Greece. He noticed something about triangles. He noticed that if you have a right triangle, which looks like this with a right angle, that this leg squared plus this leg squared is equal to this leg squared. And I know that sounds confusing. We can look over here at A, B, and C. Okay, A, if we found the area of this square, it would be 1, 2, 3, 4 times 1, 2, 3, 4. So it's 4 times 4. 4 times 4 is 16, and you can see that right here. The length of this side is 4. Okay, over here the length of this side is 3. And you can see that if you drew a square around this edge, 3 by 3, you get 9. And then if you look at this side and you add your boxes, you get 1, 2, 3, 4, 5, and that this square is going to be 25. And he noticed that this, and it struck him, this is a 3, 4, 5 triangle, and he noticed that 3, 4, and 5 just come after each other, but he noticed that 3 squared is 9, 4 squared is 16, and if you add 16 plus 9, you get 25. 16 plus 9 is equal to 25, and he thought that was pretty cool, and he tested it, and he looked around, and all kinds of triangles work like this, and he developed this little formula here. A squared plus b squared is equal to c squared. And so he named the two short edges on a right triangle, leg A and leg B, and he named the long side on a right triangle a hypotenuse. Now remember, it has to be a right triangle. It has to look like this, and he got A, B, and C. So if, for instance, this medium long side is 12, say it's feet, this one is 5, and we have to find out what this one is, we can plug it in our equation and see. A squared plus b squared plus c squared. We could draw this picture, but it's hard, and sometimes we just use the math instead of drawing the picture. Okay, A is 12, so it's going to be 12 squared. B, leg B, is 5, so it's going to be 5 to the second power. A squared plus b squared should equal c squared. Look at this, I wrote a cubed. This should be a squared. A squared plus b squared equals c squared. I tend to make little mistakes all over the place, and hopefully you catch me. Once in a while I catch myself. So this is the formula. This is our numbers, and we're trying to find out how long this side is. 12 squared is 144. 5 to the second power is 25. And that equals c squared. We still don't know, but we can add up 144 plus 25. And 4 plus 5 is 9, 4 plus 2 is 6, and 1, so it's 169. Now, if that means that 169 is equal to c, not 3, c squared. So if we wanted to find out what c was all by itself, we'd take the square root of 169, because that kind of undoes that square. Go back over to our internet, and we'll do that. Got to put that square first. Square root of 169 is equal to 13. Okay, so that should mean that c is equal to 13, and that this side should equal to 13 feet. So we've got 12 on this one, 5 on this one, and 13 over here. It's just like this right triangle with the 3, 4, 5, but this one is 5, 12, and 13. It works for all right triangles, and we can try several examples just to see. We have to make sure that you understand the parts. So learn or memorize the hypotenuse is this diagonal part across from the square, the right angle. And then we have leg A and leg B, or A and B. And then we have this formula, a squared plus b squared equals 3c squared. So let's make sure we've got that figured out. Let's try something crazy. Let's try a triangle that looks like this. This is in your book. Doesn't look exactly like this because they've got better machines for it, but they say that this is a right angle. They say that this is 3/10 of an inch, and over here is 2/5 of an inch. Okay, so we're going to use our formula, a squared plus b squared equals c squared. This is a, or this is a, this is b. It doesn't really matter. These are a and b, and this is c. Okay, so we're going to start putting in what we know. 2/5 is a, so 2/5 squared plus b, which is 3/10 squared, is equal to c squared. And then we just come down and we simplify that. 2/5 to the second power, 2 to the second is 4, and 5 to the second power is 25. So if we square 2/5, we get 4/25. And then we're going to do the same thing here. 3 to the second power is 9, and 10 to the second power is 100. Okay, and then we're going to come back and try to add these together. Now, if I can't add 25ths and 100, but I could multiply this by 4, get 16. Multiply this by 4, get 16 hundredths. Is the same as 4/25. And then 16 plus 9 is 25 hundredths equals c squared. I keep forgetting little things. Thanks for catching me on that. Now, to undo this square, a square root undoes the square. So then c, the square root of c squared, is just c. And the square root of 25 over 100 we can figure out. So c is the square root of 25 over 100. The square root of 25 is 5, and the square root of 100 is 10, and 5/10 is the same as 1/2. So c is equal to 1/2. Ta-da! Okay, that's some work, and you actually need to probably write all of these steps. You got to go through it. It takes paper. It takes time. What happens if we know what c is, but we don't know what a side is? So, for instance, we have maybe this right triangle here, and this is a right triangle. And maybe I know that this is 2.9 meters, and I know that this is 2.1 over here, but I don't know what this one is. So I'm going to go back to my formula. Just do the same thing. A squared plus b squared is equal to c squared. And I start plugging in what I know. Well, this is the hypotenuse, so it's c. Down here is a, which means this has to be b. So a squared plus 2.1 squared is equal to 2.9 squared. And we just use algebra to undo everything. So 2.1 squared, 2.1 to the second power is equal to 4.41. Alright, so that's going to be a squared plus 4.41, and 2.9 to the second power, 2.9 to the second power is equal to 8.41. You could see that because 2.9 is almost 3. 3 to the second power is 9, so that works, 8.41. And we're going to subtract to get a by itself, 4.41 from this side, and subtract 4.41 from this side, and we can see that we're going to get this is going to become 0, and 41 minus 41 is 0, and 8 minus 4 is 4, so we're going to get 4.0. So that gives us down here that a squared is equal to 4.0, because 8.41 minus 4.41 is 4.0. And the square root of a squared is the square root of 4, so a is equal to 2. Or a could be negative 2. But we're usually going to keep those positive numbers going here. A is equal to 2. Alright, that's kind of how it works. If you need help with this, I will work with you. Let me know.